NASA releasing stunning new pictures of Jupiter from the Webb Space Telescope.
The world's largest and most powerful space telescope has revealed unprecedented views of Jupiter.
So NASA is releasing new images of Jupiter.
When the James Webb Space Telescope launched from French Guiana on Christmas Day 2021, researchers expected it to provide incredible pictures of distant galaxies and star-forming regions, as well as investigate the chemical compositions of exoplanet atmospheres. And NASA's flagship space telescope has not let us down. JWST has already obtained photographs of galaxies so far away from Earth that cosmic expansion has pushed their light deep into the infrared range, which the telescope is designed to detect. So what did the JWST discover on Jupiter? Is the mystery of the giant red spot finally solved? Join us today as we bring you the astonishing new finding on Jupiter made by the James Webb Space Telescope that changes everything. Jupiter is the biggest planet in the solar system and the fifth planet from the Sun, and the gas giant has a lengthy history of surprising astronomers. This stormy region is covered with bright clouds and called for the sort of gods in Roman mythology. The Great Red Spot, the largest and most known storm, is twice as broad as the Earth. Galileo's 1610 discovery of Jupiter's four massive moons, Io, Europa, Ganymede, and Callisto, revolutionized our understanding of the cosmos and our place within it. These observations, which marked the first time celestial bodies were discovered orbiting a body other than the Earth, supported the Copernican notion that the Earth was not the center of the universe. According to NASA, Jupiter is more than twice as big as the rest of the solar system combined. Jupiter's massive size could hold more than 1,300 Earths. If Jupiter were the size of a volleyball, Earth would be the size of a blueberry. Because it was formed from gas left over from the Sun's birth, Jupiter was most likely the first planet to develop in the solar system. And if it had been roughly 80 times more massive during its birth, it would have expanded into its own star. Jupiter's orbit brings it about 480 million miles from the Sun on average, which is 5.203 times larger than the Earth-Sun distance. Jupiter's atmosphere, which is composed mostly of hydrogen and helium, is comparable to that of the Sun. At the planet's core, a fuzzy or partially dissolved core is enclosed in a fluid metallic hydrogen layer rich in helium. According to experts at the University of Colorado in Boulder, Jupiter has the greatest magnetic field of any planet in the solar system, roughly 20,000 times greater than Earth's. Because of the magnetic field's extraordinary trapping of electrons and other electrically charged particles, the planet's moons and rings regularly encounter radiation levels that are more than 1,000 times greater than those that are dangerous to humans. Radiation may destroy even well-protected spacecraft, like as NASA's Galileo probe. The world gasped in awe and disbelief as the first James Webb Telescope photographs were made public this year. These photographs of merging galaxies millions of light years distant and planets outside of our own Milky Way enthralled people all across the world with their minute details. Even experts were confused by the unique and puzzling facts that the initial data set from the James Webb Space Telescope revealed. In less than a year, this magnificent telescope has provided us with a plethora of information about our cosmos that has radically transformed our perspective on it. It seems to reason that a telescope that can see galaxies billions of light years away and lights from the beginning of the universe would have no problem providing us with photographs of our solar system in exquisite detail. The James Webb Space Telescope once again confirmed its superiority by transmitting awe-inspiring images of Jupiter, the biggest planet in our solar system and the Lord of planets. The telescope's expected 10-year mission implies that many more captivating images of our solar system are beginning to emerge. James Webb Space Observatory has already captured images of galaxies so far from Earth that cosmic expansion has pushed their light deep into the infrared area of the spectrum that the telescope is designed to detect. In addition, the Near-Infrared Spectrograph, NIRSpec, of the observatory produced the first definitive detection of carbon dioxide on an extrasolar planet when it detected the gas in the atmosphere of exoplanet WASP-39b. But JWST has also focused on nearby places. On July 27th, researchers used the telescope's powerful infrared eyes to zero in on Jupiter. The resulting photos reveal a world with both familiar and mysterious features. Principal investigator Imke DePata of the University of California, Berkeley, stated in a statement, "We hadn't really expected it to be this good. They have never seen Jupiter like this before, and it is absolutely stunning. Previously unclear photographs of its huge storms, auroras, and faint rings may now be seen in stunning detail thanks to the Webb telescope." The gas giant was captured in this composite image by combining many telescopic images. This causes a gradual shift in hue from orange and yellow in Jupiter's poles to blue and purple in the planet's equatorial zone. According to NASA, distant galaxies and thin rings may likewise photobomb the foreground. The images are supposedly so astonishing that even NASA's top specialists are stunned. Jupiter is surrounded by a brilliant aura and covered in white streaks and patches. The photographs are far more vivid than those captured by the Hubble telescope, which the James Webb telescope succeeds. Together with Thierry Fouché, a professor at the Paris Observatory, DePata supervised the international Jupiter observations. "It is simply outstanding," DePata stated in the press announcement. "We can see details on Jupiter together with its rings, tiny satellites, and even galaxies in one view." NASA unveiled in July the first set of full-color images and data captured by the Revolutionary Telescope, which revealed a cosmic extravaganza of colliding galaxies and a dying star. The telescope's near-infrared camera, NIRCam, obtained the two images of Jupiter using infrared filters to emphasize the planet's unique characteristics. The pictures were digitally colored to emphasize Jupiter's characteristics and convert infrared light, which is invisible to the human eye, into the visible spectrum. The information from telescopes like Webb is not transmitted to Earth in a small packet. Rather, it contains information about the light intensity detected by Webb's detectors. This data is received as raw data by the Space Telescope Science Institute, STSCI Webb's Mission and Science Operations Center. After processing, the data is calibrated in STSCI and submitted to MAST, the Mikulski Archive for Space Telescopes, for distribution. Scientists then translate their data into images like these during their inquiry. STSCI's personnel formally prepares Webb photographs for publication. Citizen scientists and amateur astronomers routinely search the public data repository for photographs to extract and analyze. Judy Schmidt of Modesto, California, a seasoned citizen scientist, examined these newly released Jupiter images. To construct the images showing the small satellites, she collaborated with Ricardo Hueso, a co-investigator on these data who studies planetary atmospheres at the University of the Basque Country in Spain. Schmidt claims that because Jupiter spins so rapidly, it is more difficult to deal with than more distant celestial mysteries. Furthermore, if Jupiter's distinguishing features have rotated since the images were captured and are no longer aligned, it might be challenging to merge a stack of photos into a single perspective. In order to arrange photos coherently, she must occasionally make digital changes. Jupiter, unlike Earth, is a gas giant with no solid surface. Its principal constituents are hydrogen and helium. Jupiter is claimed to have the same fundamental ingredients as a star, but was never large enough to explode into flames. It too has several rings, but they are darker and comprised of space dust rather than ice like Saturn's rings. The new photographs show Jupiter's two small moons, Amalthea and Adrastea, as well as its dimly visible rings. Amalthea, one of Jupiter's 53 named satellites, is the fifth biggest overall and the first to be discovered after the 4 Galilean moons. Amalthea is Jupiter's third closest moon, and it completes a full orbit in less than 12 hours. Amalthea was the final planetary satellite discovered directly or via the use of a telescope, as opposed to imaging equipment like as a satellite or probe. In terms of Jupiter's moons, Amalthea remains a mystery. We don't know much about Amalthea with clarity because there haven't been many in-depth observations. According to NASA, it is a rocky body with a mean radius of roughly 51.88 miles, 83.5 kilometers. It has a potato-like form, belongs to the inner moon group with Metis, Adrastea, and Thebe, and circles Jupiter in 11 hours and 54 minutes at a distance of 112 to 717 miles, or 181 to 400 kilometers. According to infrared photometry, Amalthea has a temperature of 155 Kelvin. As per studies conducted by the Galileo orbiter in the 1990s, the Moon has hills and valleys and is riddled with impact craters. It is the reddest body in our solar system, and scientists believe the colour is created by sulfuric compounds in the nearby volcanically active Jovian moon Io. One of the gossamer rings that Amalthea produces is Jupiter's faintest innermost gossamer ring. The gossamer rings are located outside of the main Jovian ring. Amalthea appears to emit more heat than it receives from the Sun. NASA speculates that this might be due to Jupiter's magnetic field or tidal forces. Because Amalthea is tidally locked to Jupiter in synchronous rotation, it constantly aligns with Jupiter along its long axis. Only 2 spacecraft, Voyager and Galileo, have ever explored Amalthea until JWST made its most recent finding. The Jovian moon was photographed by both Voyager 1 and Voyager 2 spacecraft during their 1979 flybys. The Galileo spacecraft took photographs of Amalthea with its solid-state imaging (SSI) experiment around the turn of the 21st century, expanding our understanding of the peculiar moon. It's possible to summarize the findings of a Jupiter system program which studies the dynamics and chemistry of Jupiter, its rings and its satellite system in a single picture. Webb, however, doesn't only talk about Jupiter. The Space Telescope's infrared light sheds light on formerly unseen regions of the universe. Combined with the deep field images released the other day, these images of Jupiter demonstrate the full grasp of what Webb can observe. From the faintest, most distant observable galaxies to planets and our own cosmic backyard that you can see with the naked eye from your actual backyard, says Brian Holler, a scientist at the Space Telescope Science Institute in Baltimore who helped arrange these investigations. Even more fascinating is the fact that a different NIRCam image gives a crystal clear sight at Jupiter's rings. Thebe and Metis can also be seen on Jupiter in recent pictures. Images of Jupiter shot using narrowband filters give breathtaking views of the planet's whole disk. The availability of extra information on extremely faint objects, Metis, Thebe, the main ring, and hazes in those photographs with around 1-minute exposures was a very unexpected surprise. The photographs also show Jupiter's well-known red spot, which looks white because it reflects sunlight, according to NASA. The Great Red Spot is a storm larger than Earth that has been raging for a long time, and just to the left of Jupiter's Great Red Spot is a white blob that is a black spot that is the shadow that Europa is casting on Jupiter's cloud tops. The JWST team is hopeful that further observations may allow the Space Telescope to detect comparable phenomena on Europa. Let us know what you think about the latest JWST Jupiter images in the comments section below.